Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, same tree. So basically with this problem, we have two binary trees, P and Q. And by the way, binary tree is different than binary search tree because binary search tree has some conditions on the left and right, where left has to be smaller than the root and right bigger. But this is just pure binary tree, so there is not that that condition. And you want to write a function to check if the two trees are the same or not. Okay, so by the same they means they have the same structure, but they also have the same value. So same structure means if one node has a left, the same node in that other tree should have a left, and similar thing for the right. So for example here it's the same because the values are the same, right? Same thing for the second example. Okay, so that's the core idea here. So how can we tackle it? Well, the easiest thing to do is just to do DFS on both trees at the same time. So basically just DFS on both trees. Basically we can pass a node for P, let's call it node P, and node for Q. And then we can just compare the values each time, and then go the left for both and check the subtree there, and then go the right for both and check the subtree there. So very straightforward application of DFS. The only difference is that we will need to do it on both at the same time. Okay, so what that means basically is we can define a DFS like this, and we can check each time if the node value is the same. If it's different, that means we should exit because they are not the same. So at any time, if we find that the values are different, we can return false. We will handle here like nil values reaching the end, leaf, right? Or nil after leaf, right? We'll need to handle it. But for the core idea of recursion here is that we want to go left on both, because when we are checking here the left side, we want to check this left side and this left at the same time. And when we are checking the right side, we want to check this right side at the same time with this right side. So that's the core idea. Let's say, imagine if we had even a bigger tree where you have a subtree here, you have another subtree here, you have another subtree here, you have another subtree here. So when you go this side, just consider it as like a new tree, but you need to go on this side as well. So basically we need to traverse on the left side for both. So okay, and we want to check on the right side for both at the same time. But if any of them returns false, we want to return false. So we want both to be true. Basically both to say our left side is equal, and this to say our right side are equal. If any of them says false, we should return false. So that's why we do this condition. Okay, so now we handle if one of them is null. So if either node P is null, so we can do something simpler, is none, or node Q is none. So if node P is null and node Q is not null, then there is a problem, because that means one stopped and then the other one still has some nodes below. So that means they are not structurally equal. So in that case, we want to check return. So we want to check if the easiest way to do this is just to check if node P is equal to node Q. What does this mean? Basically, if one of them is null and the other is null, this would be true. If one of them is null and the other is not null, this would be false. So this is just a way to simplify the condition. And that's pretty much it. Now we just need to call our function. So we call it with P and Q. And we return whatever we get. And we can run this. And submit. Cool, it passes. So that's pretty much the core idea here. Just DFS, you can do it either like this, or you can do an iterative approach with a stack, but both should work the same way. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.